So in this video we're going to look at the second bullet point from the specification objectives, which is how to use a calculator to determine the equation of the least squares regression line. So moving on in your booklets, your Unit 4 booklets, to page 24. The least squares regression line is the proper official statistical name for the equation of the line of best fit that we draw on a scatter graph. So when we looked at bivariate data at the start of this unit, we looked at using the line of best fit to make interpolation and extrapolation. But really we should have been calling it the least squares regression line, or the LSR line, because that's its proper name. And it's the straight line that goes through the centre of the data point. So obviously we can't draw a straight line that goes through every point unless we have perfect correlation, but we do it as best as we can, and we try to get it as close to as many of those points as possible. The idea is that it will pass through some of them where it can, and you have roughly the same amount of points above and below the line, and we looked at that at the start of Unit 4. And we want the smallest distance between the lines. So when you draw it from scratch, draw it from looking at it, which obviously we don't have to do at A level. It's not very often that we get it spot on. It's not very often that we can draw that perfect line, but there are now computer programs and softwares that can find the exact place where it needs to be so that the smallest gap in between the points and the line exists. The reason it's called the least squares regression line is because it's the line that has the least distance between those points on the line, and the smaller that distance is, the smaller the variance, so the variability of the data. And obviously that's something that we looked at in Unit 1. So you should know that the equation of any straight line is y equals mx plus c, where m is the gradient and c is the y-intercept. Now I have absolutely no idea why, but when we look at the least squares regression line, we change that mx plus c to an a plus bx. I have absolutely no idea why we've got to change that equation, and we can't just carry on using mx plus c, but you need to be aware of this new name for it. One, because when we look at using the calculator, it's labelled this way, and two, you might be asked to find A and B, and if you aren't aware of what those are, then it won't make sense to you. So just like in our y equals mx plus c equation, the number or the coefficient that is multiplying the x, so in this case it is the b, that is our gradient, and the number that is on its own, so just the constant, in this case a, is our y-intercept. So it's actually no different to the equation y equals mx plus c, it's just written in a different way. So I would highlight or draw a big circle around that on page 24. That is really, really important. You need to make sure you know, you are aware, and you are 100% confident that the equation for the least squares regression line is y equals a plus bx. So I've put 3 examples underneath there. I've tried to pick slightly harder examples so you can identify the gradient and the intercept from more complex situations, because hopefully if it was written as y equals 4 plus 2x, you could easily tell me that 4 was the intercept and 2 was the gradient. So for example A, we have y is 9x minus 17.2. So straight away we've got something that is slightly different to our equation, which is, if I can write it on here, y equals I can't write on my keyboard, plus bx. So straight away, hopefully you can see that the 9x and the 17.2 are the opposite way round in this case. That is usually because the 17.2 is negative, so rather than writing negative 17.2 plus 9x, that's why they've written it that way around. It doesn't really matter as long as you can tell the difference. So in this case, the coefficient of the x, the number that is multiplying the x, is a 9. That is our value of b, and so that is our gradient. Then the constant that is on its own is the 17.2, but be aware that it is negative. So our value for A, our y-intercept, is negative 17.2. Example B. Example B is written slightly differently. Example B is written as y minus 5 equals 0.8x. So in this question we don't have we don't have the equation in the same order. So we just need to think about what that would be. So I would just rearrange this equation in my head, or I'm going to do it on the screen just to show you here, just to help myself out. So at the moment the minus 5 is on this side of the equation. So think about rearranging equations, writing it, so it says y equals. So if I'm going to get rid of minus 5 from the left hand side, that means I'm going to plus 5. And so I need to do the same on the other side. So it's going to be plus 5. Then don't forget the 0.8x. So you can write it as 0.8x plus 5, or I've written it this way around just so it looks a little bit more like my equation at the top. Now I've rearranged that equation to make it look like y equals a plus bx. I can quite easily see that my b, my number that is multiplying my x, my coefficient of x is 0.8, and that is my gradient. And I can see that my value of a, my constant on its own, is positive 5. I've written plus 5 just so we can identify that it's positive, just to make that really clear. Obviously you don't want to make the mistake of saying it's negative just because it was minus 5 in the question when the equation wasn't rearranged. Okay, example C. So hopefully with example C, straight away you can spot the difference here, and that is that this is 3y equals 7.2 plus 0.5x. So rather than y, I've got 3y. That means that I can't use these values 7.2 and 5.05 because they are 3 times too big. However, the equation is written nicely like this here, so I can see that it is written out in the correct form. I just need to get rid of that 3. So think about what you know about algebra. Think about how you know that 3y means 3 times y. And to get rid of that times in by 3, I'm going to divide by 3. So my gradient, which is the number that is multiplying the x, the coefficient, is 5.05, but that is for 3y. So to work out what it would be for 1y, I would divide that by 3, and that would give me a gradient of 1.68. I actually think that's a recurring decimal, and I've rounded that to 3 significant figures. Same with the y-intercept. The y-intercept is my coefficient, my constant, which in this question is 7.2, but that is for 3y. So to get y on its own, I'm going to divide that by 3, and that gives me 2.4 exactly. So if you haven't done so already, I would suggest you pause the video here and you just make sure you've copied down those 3 examples. Once you've done that, I would like you to have a go at exercise 4.3b, and that is just asking you to find the gradient and intercept of some different equations, no context. I'd like you to have a go at that, please, and then mark your answers using the PowerPoint where all the answers have been put on, and then move on to the next video, which is using the calculator.